Yes. So, welcome everyone to this fourth seminar of our web seminar of our series. And today we are very pleased to host a talk by Ruth Pickering, who is the Chief Operating Officer of UNO, and she will speak from Palo Alto in California. One thing that I like of UNO is that if you go on the website of UNO, you will read the words transforming information into knowledge. You can go there and you will see that it's there. And for those of you who have attended this series of talks, such a statement won't sound new, as in some way, this is the real common topic that links all the talks in this series, because transforming information into knowledge is really one of the big challenges of the present times. And it is the objective of many tasks in linguistic computing. So I think that such challenge is perfectly epitomized by the mission of UNO as it is presented on its website. I read it. UNO's mission is that of extracting knowledge from an overwhelming quantity of unstructured and structured data. Our technology helps to overcome the information overload problem. And indeed, today, the information overload is one of the issues of our times. And we are surrounded by information, by data, and we need automatic ways to manage and exploit it. So today, I'm sure that we will learn about knowledge graphs. That is to say, collections of interlinked descriptions of, let me say, entities like objects, events, or concepts. And we will see some practical applications of knowledge graphs for both research and publishing. So the topic is much relevant for this series of webinars, and it is very exciting. And I thank very much Ruth for accepting our invitation, and I'm glad to leave her the stage to talk us about knowledge graphs and artificial intelligence, transforming data and improving content discoverability. So Ruth, thank you very much for being with us, and the stage is yours.
Thank you very much, Marco, and hello to everybody and a warm welcome from me. Thank you very much for joining this session. In terms of the agenda, I'd like to start off at the very beginning, really looking at a knowledge graph, the definition of a knowledge graph, and what we're talking about. Then I'd like to dive into the transformation of data to knowledge. As Marco said, we're all overwhelmed by this huge amount of content and information that exists and that continues to be produced every day. And information is not the same as knowledge. Then I'm going to go into some details about how artificial intelligence technology literally takes a raw piece of content, whether it's a journal article, whether it's a piece of news, whether it's a clinical trial or a patent, and literally takes that piece of text and can process it to derive meaning. I'm going to go into some details about concepts and disambiguation, and what exactly is a concept and how a concept is different from simply a keyword or a name. Then I'm going to come into some use cases and really how it can help us all today. So how can the AI technology help us deal with the problems we face in terms of the challenge of the volume of information? I'm going to focus a little bit on visualization. And then I'm going to come on to some different use cases, looking at some very different content types, from academic content to financial content. Then I'm going to leave you with some further reading, if you're interested after this talk to go into some further background in terms of journal articles and patents on the subject, and then we will open back out to questions. Do feel free at any time to put your hand up or send a question in the chat, and if not, we will answer questions at the end. So first of all, looking at knowledge graphs, and I wanted to start at the very beginning, what is knowledge? And I have this very beautiful quote from Leonardo da Vinci. The acquisition of knowledge is always of use to the intellect, because it may thus drive out useless things and retain the good. For nothing can be loved or hated unless it is first known. So when people come to talk to me at UNO, a lot of people are talking about exactly this statement of Leonardo da Vinci. So when I talk to people in the financial industry, they're overwhelmed by the quantity of things like news. They buy huge news sources with hundreds of thousands and millions of items, and they cannot find what they're looking for because information is not the same as knowledge. So what I'm really going to focus on here is how we can take all of this and derive knowledge. And starting off, what is a knowledge graph? So I think many people on this call will have heard talk about knowledge graphs. And actually, there is no universally accepted definition yet. So many people will be thinking something a little bit different. So the first definition, a knowledge graph, mainly describes the real world entities and their interrelations organized in a graph, defines possible classes and relations of entities in a schema, and allows for potentially interrelating arbitrary entities. So that's a very broad definition. I wouldn't disagree. And I would talk a little bit about the interrelating of arbitrary entities, and I would talk about inference, and we'll come on to that later. The next definition, much shorter, knowledge graphs are large networks of entities, their semantic types, properties, and relationships. I think that is too narrow. I think it doesn't tell you the true power of AI and how it can also be used to infer something that isn't written. But I won't go through all of these, but I will leave this with you to take away. Just to say that there are differences in terms of how people would describe and imagine a knowledge graph, but I'm going to move on to how we would describe it at UNO, and then I'm going to give an example. So from our perspective, I would say that a knowledge graph is something that acquires and integrates information into a dynamic knowledge base and applies a reasoner to derive new knowledge. So if you think about the way in which information and content has been structured historically, in databases, in some kind of storage or repository, it was static. It was not a dynamic environment. So as new content, as new information was added, there was no way to link it. And one of the key things about a knowledge graph is that it is not a static environment, it's a dynamic environment. And I'll come on to an example in my next slide, but that's critical in terms of all of the content, all of the information and deriving knowledge, because it's not something that's static and because language will continue to evolve. So if you summarize, first of all, knowledge graph is of course a graph, and a graph is a fantastically flexible mathematical instrument. So it can be interrogated by all kinds of different people in different ways to find different things. Secondly, a knowledge graph encodes semantics, also critical. The third part, a knowledge graph enables derivation of new knowledge through an inferential reasoning process. So this is also critical, and this is really the AI part of it. So in some cases, you may see a visualization, maybe a graph visualization. But when people take things like metadata and just connect them together in a graph visualization, that's a very different thing from a knowledge graph, because you're just connecting static data. You're not actually deriving knowledge. So we need to be sure that the knowledge graph itself is actually using AI and is actually using some kind of reasoning to derive new knowledge, not simply connecting existing data. And the fourth point, a knowledge graph will evolve with new data. So as we all know today, none of us, even teams of people, cannot read all of the new content information that is published every day. Whereas what machines and what artificial intelligence is brilliant at doing is it can deal with unlimited amounts of data, and it can treat all the data the same because it's completely unbiased. And the critical thing that as it is doing that, it is evolving, it is learning, and it is understanding. So to give an example really of exactly how this works and why the fact that a knowledge graph is dynamic is so important. What I'm showing you here is a slide that looks at two concepts. The two concepts are tariffs and trade wars. And this is showing you news articles that are being ingested real time every day, about 10,000 items a day. And it's showing you how the relationship of these two concepts is changing. So every time you see any of these bars move, that is how that relationship and the importance of those two things is actually changing dynamically in real time. So as we sit here watching this on this call, there's simply no way that any of us could possibly have been reading all of the items of news and understand how these things are changing, how one relationship might become less prominent, another more prominent, and how things can completely restructure in terms of the hierarchy of importance. So here we see the International Monetary Fund suddenly shoot up, for example. And I think you will have noticed further down in the bar chart, many of the bars will have been moving as I've been talking. So this is really information being ingested real time from news sources, but we can see now how everything is changing. And now we have the International Monetary Fund at the top, and now it's moved again. So hopefully that gives a demonstration of the criticality of having a dynamic environment, and that's how you will be able to derive knowledge. So in the next section, I'm going to talk a little bit about how you can take the raw data, use artificial intelligence technology, and then start to derive knowledge. So this is a very high level slide, and I'm going to talk you through it from left to right. You know, we use a very specific blend of computational linguistics, machine learning, and graph theory to build our knowledge graph. What you see on the left-hand side is unstructured text. So it could be any type of different content. It could be journal articles, books, book chapters, news. It could be short items of news, long items of news. It could be things like government reports. So it doesn't matter the type of content. It does have to be digitized content. And what happens is that content can be ingested real time or daily or as frequently as it's published. And it doesn't matter how much. So the volume, because you're going to be using an artificial intelligence network, you can scale that. So it doesn't matter whether you have 10,000 items or 10 million items, you'll be able to scale that and ingest as much content as is available on a daily basis. Then what you see in the middle of this diagram is the technology. So it's a series of algorithms. And what the algorithms are trying to do is to recreate a neural network. So what they're trying to do is to recreate the way in which any of us on this call think about and process information. So as they read the content, they understand the context, they understand what's important. And in that way, we as humans are extracting meaning from the text. And the way in which the algorithms are doing it, they're understanding the context, they're applying a topic model, and they're identifying meaning in the form of concepts. And those concepts are then promoted into this enormous multidimensional graph network that you see on the right-hand side. So the graph network that we're looking at here on the right, as we just showed in the previous slide, it's not something static, it's dynamic. So as all of this new information is constantly being ingested and then projected into the knowledge graph, the connections will change. So the relationships between concepts can change. Some things can become more important, less important, and you can also have new concepts. So as language evolves, if a new word is being used for the same concept, that will be treated as a synonym. But if a new concept comes, so for example, November 2019, COVID-19, here we are in April 2021, and we have about 15 more variants. These are all new concepts. They did not exist in the past. So they will be in the knowledge graph with a definition, and they will be connected to the related things. And in our world, the knowledge graph is interdisciplinary, so it contains all different types of information. So you would find information about history in one place, you would find economics in another place, and all of these different types of information, if there are connections, will be made, but you will also be able to find very specifically what you're looking for, rather than finding it polluted and messed up with all the other irrelevant information, because the knowledge has understood the context and meaning. So how does that work in real time? So in terms of the data science pipeline, what you see on the left-hand side is any kind of raw document coming into the pipeline. And the first thing we do is real-time ingestion and processing. So we literally take the text and metadata. So in a traditional environment, pre-AI, metadata would have been probably the only way of identifying documents and subsequent search. And therefore, if the metadata is poor, if it's varied, if it's lacking, if it uses terminology that has changed over time, you will not get good results. So the fact that technology now is able to read the full text is a huge leap forward. The next thing that we'll do with the content is we will apply topic modeling. And that enables us to understand the domain, the relevance, what type of content it's about. The third thing we'll do is concept extraction. And I'll talk later about concepts. In this specific example, you can see a picture of Jaguar the cat and a picture of Jaguar the car. And I'll explain to you later how the disambiguation works and how the artificial intelligence is able to understand that those two things, although they have the same name, the same word, have different definitions, they have different topic hierarchies, and they will be in completely different semantic vector spaces in the knowledge graph. After that, we apply a series of statistical analysis, inference extraction, and event recognition, and then we create the knowledge graph. And you can see an example there. The knowledge graph has multiple layers with different connections. What I'd like to do now is to go through a very, very specific example showing a piece of content to explain literally how it works at that level. So what you can see here on the left-hand side is literally a raw piece of content, a piece of text. In this example, I'm using a piece of news. So the way the pipeline works in terms of the artificial intelligence beginning the concept extraction is the first thing that we would do is we would take a piece of news and we would split it into what we call text snippets, so into pieces of text, smaller pieces of text. The next thing we do is once we've taken the item of content and split it into smaller pieces of text, we perform concept extraction. And then for each snippet, we extract all of the relevant concepts. So if I look at this example on the right-hand side, the first piece of text that starts, while other asset classes don't like increased volatility. If you look underneath that, you will see two concepts. You'll see a concept ID, a concept name, and a pertinence. So everything in the knowledge graph is about maths. So the ID tells us what that concept is. The concept name, dividend, that is the word used to describe the concept. It could be a single word, it could be a couple of words, it could be a group of words. And then the pertinence tells us the relevance of that concept in that article. And that you can use in a knowledge graph to surface more relevant content versus less relevant content, depending on what the user is looking to find. And so if we look at the full example, this is the full piece of text. And what we can see underneath is a list of the concepts that have been matched. So you can see it's a huge range of different types of content, everything from Great Recession to investor, to cash flow, to price, to Chicago Board Options Exchange. And so we can see that the concept in this world can be a single word, a couple of words, or even 4 words. We can see that every single concept has an ID, an identifier, and every single concept always has a score. And that's how you can understand the importance of different concepts in relation to other concepts and how you can help people find the most relevant things in terms of their particular search query. So I'm going to move on to now to a section on concepts and disambiguation. We've talked a little bit about concepts so far, but I'm going to go to the next level of depth and clarity in terms of what I mean by a concept and how we can disambiguate. So first of all, going back to the concept-based approach, the conceptualization of information to produce knowledge. So in our world, a concept, which is, as I said, a single word or a couple of words or a group of words, always carries with it a significance and an inference. So a concept is not just what we would historically call a keyword. It's not simply a word or a term. It can be a word, but it always has a definition. So in this example, and we looked at it previously, we have Jaguar. So the word Jaguar is the same whether you're talking about an animal, a car, or a World War II tank, or there are many other definitions that could be associated with the word Jaguar. So what's important about a concept is that a concept has a definition. So when I'm talking about Jaguar, I know, because of its definition, whether I'm talking about the cat or the car. Additionally, each concept, in addition to the definition, will have a topic and subtopics. So we can see in the left-hand example on this page that Jaguar the cat has the topic of nature, and the subtopic is zoology. And it also has a topic of nature and the subtopic of wildlife. When we look on the right-hand side and we see Jaguar the car, we see that it has a topic of engineering and the subtopic of car. And we also see it can be found in the topic of marketing with a subtopic of brands. So a concept is an atomic unit of information because it carries these parameters, this additional information with it. And that's going to be critical to the disambiguation. So how does the artificial intelligence extract new concepts? So I mentioned earlier that we're trying to recreate a neural network model. So the way in which the AI technology does this is that there is a piece of text and we're reading the piece of text algorithmically. And as the technology reads the text, it starts to understand important concepts. And here we can see on the left-hand side in the example, in purple, we've highlighted the words monetary policy. So it's reading the text, it's seeing this, it's understanding that it has important meaning, and it's extracting that for evaluation. It's calling it a candidate concept, monetary policy. It then gets promoted and it goes to a description lookup because monetary policy is not a concept. It has to have a definition. So it will go to the UNO knowledge base to find a definition. So at UNO, we're a technology company. We don't make up definitions. So we will go to reference sources to find a definition. So in this case, we find a definition of monetary policy, which is the process by which the monetary authority of a country controls the supply of money. So when we have a good match, we understand that monetary policy in this example is relevant. It means the definition that I showed you in the box, and then that concept can be added to the knowledge base, and it can be enhanced, further content can be added, further connections can be made. If there was a situation where a concept is promoted, but a definition cannot be found, I can give you an example of neurophotonics, which was ingested and fell out of the machine because it was identified as a concept. It was promoted, but we couldn't find a definition. Then we have a semi-manual process where a team of people will look for a definition. If you think about something like COVID-19 in November 2019, again, it's extracted, it's promoted. At that time, there isn't a definition in a reference source. It would have been termed coronavirus. So to find a very specific definition, you have to go outside the standard process. So why are we talking here about concepts, and why are we not happy just to continue using keywords as we have done historically? So concepts are very important because language will change over time. So if I give you an example on the left-hand side of Brexit. So Brexit was a term that started being used frequently in about 2016. But actually, Brexit wasn't something new. The United Kingdom withdrawal from the European Union is something that we've all been talking about for quite a long time. So when you are searching for information, whether you use the term Brexit or whether you use the term United Kingdom withdrawal from the European Union, it's the same concept. You're talking about the same thing, and you want to surface all of the same information.
Ruth, we can't hear you. We can't hear you anymore. Am I the only one who can't hear Ruth?
Am I back?
No, she's gone.
Oh.
Now you are back. Okay.
I'm back. Okay.
Right.
Great. Okay, let me know if anything happens again. So, and then on the right-hand side, you see this example of Nurofen. Nurofen is a specific brand name, actually, for the drug ibuprofen. So if you were doing a search for that, you wouldn't want to simply get that brand. You would want to understand that it was linked to that drug. And then looking at disambiguation and what it might mean. If you look for the word depression, you could be looking for a geologic depression. You could be looking for a meteorologic depression, a low pressure area. You could be looking for an economic depression. You might be looking for the Great Depression, the Long Depression, the Depression of 2021. You could also be looking for depression, the mood. In fact, you probably are in the middle of a pandemic. You could be looking for a physiological depression or a major depressive disorder. So the key word or the term itself isn't enough. You have to have a concept-based approach where every single concept or group of words or word has a definition and it actually is this atomic unit of information. Another example of why it's so important that you use an intelligent technology is that if you go back historically, there will be content that will not use the term that we use today. So in this example, we're looking at some text about 3D printing. The first example is from 2004 and the second from 1995. In these pieces of text, the word 3D printing isn't mentioned because it wasn't commonly in use at that time, but they're about 3D printing. So when you use an artificial intelligence type technology that actually reads the full text and understands what it's reading and understands the context and the meaning, you will find things that will be lost in a more traditional environment. So I'm going to talk a little bit now about how all of this technology can actually help us. It can help us on a day-to-day level in terms of discoverability and finding what we're looking for. So I wanted to give an example. If you went today, if you were looking for belongingness and you went today to a traditional search engine and you put in the word belongingness, you will find 1,230,000 results. And this will be the first page. So here we get a definition. It's very useful. Two different definitions, one on the left and one on the right. So it's helpful. If we go here, we do the same search in an academic platform. We get this list of results. Doesn't really tell us anything. We would then have to click into each of these results and read them. In a knowledge graph environment, you can put in the what term, and we do have a definition on the left, but you will immediately be drawn into the visualization on the right. So we talked about belongingness, and then you can immediately understand the context. You can see the perspective. You see this constellation of relevant terms that relate to it, and it gives you a sense of meaning. It helps you know what the term is about. It helps you understand. So we can see it links to stereotype, to group dynamics, to self-esteem, to group cohesiveness. So immediately, with one click, the visualization is helping. And what the knowledge graph has done is it's read tens of thousands, millions of items of text, and it's understood that these are the relationships, these are the related concepts. So it's helping us. So we haven't got time to read all of that background content. So the knowledge graph has done that for us, and it's able to visualize in front of us in a single glance and help us to understand and to learn what it's about, how it's relevant, and how it's associated. And that kind of visualization hasn't been available until relatively recently. I'm going to go into more detail about visualization and how the artificial intelligence powered visualization can really help us to discover things that we might not even know to look for in the first place. So I'm going to take an example, and I'm going to start here with the MMR vaccine. And I've chosen that deliberately because it's a very controversial area. And sometimes you have a lot of talk about AI and bias. And actually, I'm going to show you a completely unbiased example of AI. Because artificial intelligence is recreating what humans do. So of course, humans can be biased. And if you want to recreate that, you can, but not necessarily. So what you see here on the right-hand side in the graph is the concept in MMR vaccine. You also have the concept autism, and you have controversies in autism. And you have many, many other smaller concepts that are linked in some way. But the key point of this is that you can see the MMR vaccine and you can see how it links to these other things. And the knowledge graph isn't telling you it does or does not cause autism. It is telling you that there is a link, and it's also telling you that there are controversies. And then it is for the reader to explore all of those links, to find the source documentation and to make their decision. So in this case, a knowledge graph isn't giving you the answer, but it is helping you work through the huge amount of information. It is giving you a brilliant way to understand the problem, to understand the context, and then to come to your own conclusion. And then in another example, I'm showing here at the top, we have early onset Alzheimer's disease, and on the bottom, we have a link to physical exercise. So in this example, actually a colleague of mine had a family member diagnosed with early onset Alzheimer's disease. And they remembered reading something about a link to physical exercise that could actually help improve it, so delay the onset, but they couldn't find any relevant documentation. So in this case, we use the knowledge graph, which clearly identifies that there is a link, and it clearly identifies all of the relationships, and it helps you underneath find the underlying data sources, which you can then read about to understand. So I'm going to move on now to some very, very different content types and some very, very different use cases of different people. So first of all, I want to look at some financial documents. So one of the big use cases is in the financial domain, and at Cattolica, you yourselves actually also use this product. So in earnings season, all of the public companies publish their results. They have a results call, and then they publish the transcript. So the transcript is of that call. And it could be anything from 40 to 120 pages. And over a 6-week period, all of the companies publish these. So the analysts need to really, really quickly read all of these documents and publish some kind of report quicker than any of their competitors. So what we're able to do using AI technology here is that the artificial intelligence technology can ingest and read those documents in a matter of minutes. And having read them, what it can then do is show you, if you're an analyst and you need to understand what's been written, it can show you all of the concepts in the document. So on the left-hand side, you're looking at a comparison of 2 transcripts. So rather than an individual analyst having to read through dozens and dozens of pages and compare the current transcript to the previous transcript 3 months ago and to understand what's different and then to write their report, they're able at a single glance to see on the screen what was covered in the previous transcript, what is covered in this transcript. And then on the right-hand side, it can give you a count, so you can see exactly what's the same. So I can say I want to see all of the things that are the same. So I can see on the left-hand side that there are 19 mentions of customers, and on the right-hand side, 24 mentions. I can see that on the left-hand side, Amazon, the company, was mentioned 18 times, and on the right-hand side, 14 times, and so on and so forth. And it's not just about giving us things like count or the concepts. It will also take us to the exact section of the document where the term is mentioned. So to somebody who has a huge amount of information to digest in a very short amount of time, it can save us an enormous amount of effort and get us to help write our report even quicker. And if you also want to understand a little bit about trends and tone, so it's not simply about how often a word is mentioned and whether a word was or wasn't mentioned, it will take you to this section of the text. And so you can actually compare the tone of what has been written and say, when this term, logistics, was mentioned the previous time, was it being mentioned positively or negatively? So the artificial intelligence in this case, and knowledge graph technology, can really help a huge amount in terms of dealing with the volume of information and also understanding it and finding what you want and getting to the critical aspects of it. And finally, in this same vein, looking at anomaly detection. So we can all read huge amounts of information, but not to the volume that a system, an AI system, could. And so we might spot some changes or some anomalies. But what the technology is able to do is to literally plot for any month or for any week or for any day what's changed. So what you can see here in this knowledge graph representation. So the green things are showing you concepts that have been added. The red things are showing you concepts that have disappeared or changed. So you can look at anything, and in this case, we're looking at a company, Apple Inc. We can understand how things have changed in relation to that company simply at a glance, rather than having to read through thousands and thousands of news articles, transcripts, etc., to understand those changes. It can explain to us relationships that have been built recently or that have changed recently. And it can also just compare 2 dates in time. So if you want to understand over a specific time window. So incredibly useful in terms of a use case of seeing how things have changed. And I wanted to use a specific publisher use case. One of the biggest things for publishers is to really understand their content. And we talked a little bit at the beginning about how traditional environments use metadata. And the metadata may have gaps, it may be sparse, and so your knowledge or your understanding of content may be limited in that respect. And what an AI technology is able to do, because it's going to read the full text algorithmically, and it's unlimited in terms of how much text it can read, it can tell you exactly what is contained in any collection of content. And on the left-hand side, you can see content broken down by topic, and you can also break it down by concepts. And what's really interesting on the right-hand side is if you are interested to understand how much you've published on a certain topic, you can literally understand at item level how many documents have been published that are relevant to that concept or topic, and you can understand over time how much you've published on a range of topics. So it gives you a really amazing, incredible understanding of any content set, what's contained, and you can understand how that's changing over time. So I'm going to talk a little bit now, and then I'm going to open up for questions about some further background reading and some papers and some patents that I think might be interesting to the people on the call. So first of all, here we have a list of 5 different articles. So if you're interested to read them, so Ruggero Grammatica and Tiziana Di Matteo are actually both Italians. They wrote most of these papers when they were doing research at King's College London. And this was the foundations of the knowledge graph that we have built at UNO today. So there's a series of quite interesting papers. The first one is looking at stock correlation, and that relates back to the example I gave you in the financial domain. The second one is looking at random and frozen states in complex triangulations. The third one is a dynamical generalized Hurst component as a tool to monitor unstable periods in financial time series. Then we have the fourth one on exploring complex networks via topological embedding on surfaces. And finally, using the same graph theory for drug repurposing, which is a very interesting use case. So if people are interested, I thought you might like to read those to follow up on. And finally, before we open out into questions, there are a couple of patents around the technology which are also very, very interesting in terms of background reading about knowledge graphs. The first one is looking at information networks with linked information nodes. And the second one is looking at structuring data in a knowledge graph. So at this point, I'm going to hand back to Marco, and I'm very delighted to open out for questions.
Thank you so much, Ruth. Already 40 minutes passed, and this is a good sign that I did not get bored, but I still want to hear you talking about more things related to UNO and to knowledge graphs. And I appreciate so much the papers that you suggested, and I saw that they are really a sign of the degree of interdisciplinarity in this area. I could see that one paper among those that you suggested is published in the Physical Review, and another is published in the Philosophical magazine. So disciplines and the boundaries between the disciplines that are not there anymore, and I'm sure that people from different backgrounds could appreciate your talks. I did it from the computational linguistics background, and but I have a number of questions, as you can see here. But I would like to open the discussion and leave to the others the opportunity to ask questions. I remind you that you can ask questions by raising your hand or by writing a question in the chat. So, time for questions. Who breaks the ice?
While we're waiting for questions, Marco, I thought I'd talk a little bit about your interdisciplinarity point. So yes, I totally agree. And I think one of the things about our philosophy of knowledge graphs is that great discovery in the future will come from the intersection of different domains. So when you look at the application of AI technology and knowledge graphs, you do find some specific groups of researchers or companies that will focus on a single domain, you know, biomedicine, technology, finance, etc. But very specifically at UNO, we wanted to make sure that we could ingest every single different type of content. Because if you don't ingest across all of the domains of knowledge, you will not be able to make those connections. And so one of the reasons that our first kind of project working with our neighbors here at Stanford University was to create UNODiscover, was because we wanted to be able to ingest, we wanted our algorithms to be able to read all of the different types of content. And as you know, scientific content, economic content is structured very differently from humanities content, social sciences content. So it was very important to teach the algorithms to read all of those different formats, to find the unexpected connections, which you will only get if you mix all of the different disciplines together.
Well, this is really a big challenge. And I perfectly remember that my mentor, Father Roberto Busa, one of the pioneers in linguistic computing, was so proud to say that he had a course at the Polytechnic here in Milan at the Faculty of Engineering with the name philosophy in the name of the course. And that was the first time that this happened at the Polytechnic here in Milan. And he was very proud of talking about philosophy to engineers. So please, this is the time for questions. Otherwise, I will start with mine. There is one. Guido Consonni, a statistician, professor of statistics from our university.
Hello, everybody. Yes,
good to see you.
As Marco was saying, I'm a statistician, so I was interested in your talk. My question is this. When you relate concepts to other things, do you take into account uncertainty in any way? And if you do take uncertainty into account, how do you do that explicitly in your graph?
That's a very good question, and I'll have to talk you through a few scenarios. So we have different ways of treating different types of information for different use cases. So in the academic UNODiscover knowledge graph, we ingest all different domains of information, and we are interested in relationships between all different types of concepts. So any concept, whether it's a person, a company, just literally anything from belongingness to Henry VIII, etc. When we ingest content in our finance pipelines for finance customers, they are interested largely in the relationship between a concept to a company. So it's very specifically focused on that. So to your point about uncertainty, all of the algorithms do have a mathematical basis. So there is always the question of precision versus recall. And we have a lot of different models that we would use in different cases. So I would say it's not a one-size-fits-all model. But where people are looking for a very, very high degree of precision, then of course you're going to set your kind of uncertainty threshold at a higher rate. If you are looking to capture more broadly, which may introduce some noise, you can set a lower threshold. But I don't know, Guido, if that helps you in terms of your question.
Yes, I think it does. I know, knowledge graph myself from the community that Judea Pearl at the University of California, Los Angeles has developed. And in that case, there is an explicit probabilistic relationship between the various nodes. But probably, they are much simpler than your graphs. And so if I have a small domain of knowledge, then I can encapsulate these dependency in terms of uncertainty through probability. Simply it's probability. So I was wondering whether you use probability or you use, say, other concepts like fuzzy sets or, possibly other types of uncertainty quantifications.
So it's a complex set of algorithms, and we do use different mixes in terms of the different type of end use case. So again, if I go back to our academic product, we are interested in understanding inference. So it's not simply about understanding that two concepts have been mentioned in a piece of text and taking you there and then being able to prove that. It's also about understanding that in the multidimensional semantic vector space, two planes of information are very closely related. And therefore, even if something hasn't been published, it is likely that there is a connection. So we would call that an inference. Whereas if I'm looking at financial information, in finance, in the world of finance, everything has to be completely transparent and I have to prove that connection. So I cannot sell you a financial product like an index on a probabilistic connection. It has to be literally proven. And so if somebody says to me, why did you put this company in this basket of stocks? I will go all the way back through and I will find the piece of text that shows the relationship and the score of that. So different things in different contexts, but I think inference and when you say probabilistic, I think that's what you're meaning is one of the most exciting things in terms of unexpected connections and future research. And it's also one of the things that a knowledge graph can do so much better than any kind of human research.
Okay, thanks a lot.
Is there any other question? So I will ask one. While building the UNO knowledge base, did you use or exploit external lexical resources already available, like, for instance, the Princeton WordNet?
So in our world, we've created our own infrastructure and it's all of our own algorithms. So for inspiration, we've done a lot of research looking at different things, but we don't import. So for example, we don't import any other kind of structure into our knowledge base. So no, it is something, Marco, that we've built ourselves in our own infrastructure. But what were you thinking?
I'm thinking about the kind of semantic relations holding between the words in these kind of resources, like, for instance, the WordNet, relations like synonymity and antonymy, and synonymy, antonymy, troponymy, hyperonymy, hyponymy, that are recorded there, that are lexicalized, and that can help you in some way to design the graphs between the words in your knowledge graph.
So in terms of synonyms, we do recognize synonyms. I think the point is, in the first instance, we need to read the full text. So if you gave me a list of terms, and that list might include Java and depression and bank and all kinds of things which are very ambiguous, then I can't tell from a list what you're talking about. So in the first instance, for the artificial intelligence to work, you need to be able to read the full text, because in reading the full text, you understand context and meaning. But in terms of beyond that, then yes, you can use a kind of synonym approach.
I see. There is a question from. You can write a question in the chat. There is a question from the chat. From somebody who does. Can you read the chat?
Yeah. I'm going to stop sharing because I can't see the chat, but I'm going to go into the
so
chat.
I will read it for you.
Okay.
Here it is. This is a question. So I will. Can you read it?
I can read this one, though. Is it the multiple studies?
Exactly.
I read it for everybody in case people can't see it. So multiple studies have found that applying machine learning to ordinary human language results in human-like semantic biases, replicating patterns of sexism, racism, and other biases in our language. Your example of AI not being biased does not actually address these issues. Could you speak to this specifically? Yes, this is a great question. So it's absolutely true. As I said, artificial intelligence, or people sometimes call augmented intelligence, you can recreate the biases that a human might have. So when you start training AI algorithms, you have to be very careful about compiling a correct training data set. And you need to make sure that your training data set is broad enough. And fundamentally, in a knowledge graph environment, the more content, the broader content, the wider content, the better. So if, for example, you only included content by specific publishers in a specific date range, you would absolutely be potentially including bias. So I think there's a number of biases that you might be concerned about. You've mentioned sexism and racism. That's definitely biases to be concerned about. There are other biases that specific publishers might have. So if you consider an environment that is built, a publisher would want specific content to be surfaced. So again, you need to be careful that the AI technology you're using doesn't favor a specific type of content or a specific publisher's content above other contents. So it's absolutely possible for there to be bias, and it's to do with the way in which you pull together the initial training data set and the way in which you continue to maintain a very broad data set that will help address the bias point.
Any further question? Here it is.
So there's a final one I can see. It says, sorry, I missed the beginning of the webinar, but should information safety be a concern for us? So when you say information safety, I think you're probably talking about personal information. So I think we should all be careful about our own personal information. Before you click through on any site, make sure you do read the terms and conditions. In terms of what I've covered today, the knowledge graph that we build and use does not contain personal information. That's not the kind of technology we're doing. There are companies who do that. So I think before you join any kind of social media networks, things like that, do be very careful about your information because you don't know where it's going. So yes, we didn't specifically talk about that as this webinar because the content that we're using in our knowledge graph isn't containing personal information. It's all public domain information.
Well, Ruth, you talked to us about concepts, and as you know, the very term concept has very different definitions, and philosophers could teach us about it. And well, as you know, in Milan, we work on applying some principles of the linked data paradigm to interlink the contents in terms of data and metadata of linguistic resources, lexical resources, and textual resources. I was thinking about the fact that one of the important classes of a widely used model to represent the information stored in lexical resources called OntoLex-Lemon is the lexical concept class. The lexical concept class then is evoked by words, and it is connected to a sense that is the lexicalization of this concept, of this lexical concept, because everything deals with words, and all your knowledge base is organized into relations between concepts that are lexicalized, that are represented in text by words. I wonder if you think that it might be helpful for you and for the community, and also for us, to relate your concepts to the lexical, to the representation of them in terms of the class lexical concept of a widely used model in representing lexical resources like OntoLex-Lemon.
I think it's very interesting, and I think the relationship of linked data and kind of AI technologies, which I would say are complementary. So if I would look at linked data, I would say it was focused on the linkage of entities, mainly on people and works through the use of identifiers. And I would say the linkage is somewhat brittle, but because the same identifier is not used for the same entity, or the two won't link. And there are also predefined entities. And so the identifier that's created to represent one and only one entity. But in many ways, I think they serve the same function as a controlled access point in traditional cataloging. And I would say that in contrast, the way in which UNO is designed to work with full text and focuses on automated concept extraction, it just has no predefined topics. The concepts are generated based on the content of the full text, and the focus is more on the concept and automated analysis through AI. So I think the two are very complementary. So I think, Marco, it's a very interesting area. We should have a follow-up conversation.
Sure. I see a lot of space of collaboration between us on this. So we will keep in touch for sure on this, and we will meet in Milan in December. Any other question?
Marco, I'd like to say if anybody would like to email any further questions, I didn't put my email actually on the slides, but it's ruth@uno.com. And Guido, if you'd like me to connect you with somebody in our team, more of a kind of statistical approach, I'm very happy to follow up on the details of your question. And anybody else, do feel free to email anything that comes to mind after this webinar. And thank you very much, Marco, for inviting me. And thank you very much, everybody, for attending.
We thank you very much, and I must tell you that this is one of the most attended seminars in our series. So I was sure that this topic was very attractive and exciting. And you were very clear. You fit perfectly our very multidisciplinary audience today, and I hope that everyone, I'm sure that everyone enjoyed the talk and the topic. And so thank you very much again, Ruth. I hope to, we will stay in touch and hope to meet you in person soon in Milan or in California. I would love to come and visit you, of course. The weather is much better in December there. And so thank you very much again. And I remind to all the others that on May the 6th, we will have another webinar of the series. This time it will be in Italian, and it will be given by a representative of Google. So we will meet again in a couple of weeks, always Thursday afternoon, 4 p.m. Italian time. And grazie mille, Ruth. Thank you very much.
Thank you. Great to talk to you all today. Thank you very much.
Bye-bye.
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 Bye bye. Ciao.
Grazie Guido. Ciao.
Ciao, ciao, ciao.